Hi, welcome to part 4 of how they made these 3D fractals in Desmos. If you haven't checked out the previous parts, you probably should. While this part doesn't directly build on the previous ones, the final part will, and you won't want to miss that one. So check out the previous ones. I would also like to start this video with a few corrections from previous videos about the fractal generator. First of all, what I called a circle in the first video I made on the subject is actually an open disk. Second, while I did make path tracing in Desmos, I didn't really make RTX. RTX relies on a different algorithm and also uses a machine learning model to get rid of noise, even if very few samples are calculated per frame. Let's now skip ahead to the second video in that how-to series, because I made some errors there as well. In particular, I stated that RGB triplets have to be between 0 and 1. The lower bound of 0 makes sense, negative color doesn't make any sense. However, the upper bound of 1 does not always make sense. Light colors, for example, can be greater than 1, and in fact are almost always greater than 1. This is because these are absolute light intensities, which have no reason to be limited to such an arbitrary bound as 1, which is actually oftentimes too dark. For albedo, on the other hand, this upper bound of 1 generally does apply, because the albedo tells you how much light reflects off of an object. An albedo greater than 1 would mean that you get more light than what you started with upon reflection, a violation of the conservation of energy principle. Anyway, all that being said, let's begin. Today, we're finally going to talk about the elephant in the room, Desmos graphing calculator. So far, I've been assaulting your mind with the theory and algorithms and a torrential downpour of graphics geekiness, all while avoiding the difficult problem of implementing that stuff in Desmos. How are we supposed to make 3D fractals in a graphing calculator of all things? Well, first of all, I have something to tell you. Desmos is not a graphing calculator. Actually, I'm lying. Desmos is not just a graphing calculator, it's also a programming language. A very strange, convoluted, unusual programming language, but a programming language nonetheless. And while this paradigm shift doesn't change the way Desmos itself works, I hope it'll get you to better understand how I'm doing what I'm doing with Desmos. Desmos also has a lot of powerful features that might not be obvious to a casual user. Some of these are buried in the official documentation. Others, last I checked, weren't even there at all. So with all that out of the way, let's get started. The underlying mechanism behind the fractal generator is coordinate points. In Desmos, you can type out an ordered pair to represent a 2D coordinate point. These coordinate points will show up on the screen like so. However, you might notice that in the fractal generator we have all these fancy colors for each point. Where do those come from? We define a color with the RGB function. Note that while in computer graphics, RGB color channels are often normalized to values between 0 and 1, in Desmos they are integers between 0 and 255. Anyway, after defining this color, we can set the point's color to that color. Of course, this doesn't help us that much when it comes to the fractal generator. In some of my fractals, I had literally hundreds of thousands of points. It would be impractical to create that many expressions. This is why it's fortunate that Desmos has lists. To create a list, just type a pair of square brackets and put each element inside, separated by commas. And there we have a list of points. How do you assign colors to these point lists then? For that, just use the list of colors. A list of colors applied to a list of points will automatically apply the nth color to the nth point. Now, one thing to note is that lists can only have up to 10,000 elements. I'll tell you how I got around this restriction in part 5. Another neat, potentially overlooked feature of Desmos is Piecewises. These are the if statements of Desmos. As an example, here's the absolute value function implemented with Piecewises. It's equal to x if x is greater than 0, and otherwise equal to negative x. These are super useful for any kind of conditional logic, of which this project was overflowing. Okay, here's one of my favorite features of the bunch, and really one of the most important. Actions. Actions are pretty cool. They let you update the value of the variable, like so. They can even be put into Piecewises for conditional execution. You can even run multiple at once. A very related function is the ticker, which lets you put actions automatically on a fixed time step, say every 60th of a second. A very important thing I have to point out in regard to actions is how they're executed. One might think that all these actions here execute in sequence. Here you can see that we have the variables a and b both equal to 1. The first action adds 1 to A, and the second action adds A to B. You might expect A to be increased to 2 when we click this button. Then you expect B to increase to 3 since we're adding A to it and A is now equal to 2. Except this doesn't happen at all because Desmos actions are all executed simultaneously. To the second action, it's as if A is still 1. So that's actions. However, I really think that the heart of this project, along with how many of these projects work in general, lies in how Desmos variables actually work. This is where I want to re-emphasize that Desmos is a programming language. So when you define a Desmos variable, you can in turn define another variable that depends on the value of that first variable. When you update the first variable, the second one changes as well to reflect that update. These chains of execution can be extremely long, spanning tens or even hundreds of variables. This is analogous to something like this in a normal programming language. You can even augment this with actions to create even longer chains of execution, update the first variable in the chain of the action, and you can now use all of the updated values for its dependencies in future actions. This is really how I created complex algorithms in the 3D fractal generator. I'll get into a few specific examples of these algorithms in part 5 where we actually dive deep into how this thing works and how I made it. So that's all I wanted to show you for this video. Stay tuned to part 5 where everything we've learned so far will come together as I show you how the entire engine works within Desmos. Thanks for watching.